Welcome to the Advanced Cloud Leaderboard tutorial. This tutorial builds upon previous Cloud Leaderboard tutorials that I've made. If you haven't already done those, I would recommend doing those so that you're familiar with the code and know what's going on. Whether you've done those or not, you'll still have to remix the basic Cloud Leaderboard project from the RokCoder tutorials projects. The link for this is in the introduction to this YouTube video. The reason for this is to ensure that your code is exactly the same as we'll be building upon it, and also because there are some costumes in there that you will need for this advanced leaderboard. So when you've hit the link, you should see a screen like this in front of you, and you're going to need to hit the remix button as we're building upon this project. The first change I'm going to make is we're in the game sprite, and it's saying we're not using the basic game. I made a nicer game for the demo, but the basic game is one where we can enter scores manually, which is better for testing out a new system. So set basic game to true. And what we're going to do, we're going to go into the high scores sprite, and we're going to neaten things up a bit before we actually start building on it. There are a few things that can be improved. Let's have a look at the initialize high score receiver. So a lot of initialization goes on here, a lot of loops. This will be far better placed in a non-refresh custom block. So I'm going to create a new block called initialize. I'm going to make it run without screen refresh so that all the loops are guaranteed to run very quickly. And let's see what we're going to bring down from here. I'm going to leave this section and bring all of this section down, as this is all initializing data. I'll leave the hide here. That goes up there. And I'll leave the broadcast there. In fact, I don't need that broadcast because all that's doing is erase all. And that would actually be better done by the rest of the project. It doesn't need to be handled by the high score code. So I'm going to actually remove the hide high scores receiver and remove that broadcast. I'm going to take this decode high scores, put it there in the initialize high scores, and the rest of this initialization code is all initializing data. I'm going to put all of that in the new initialize block. Going back up here, we're going to have to call the initialize block, so we'll put that in under hide. So we're going to hide the sprite, initialize all the data, get the username, and decode the high scores. So essentially, it's doing the same thing, but it's doing it in a much neater manner. One more subtle change I'm going to make is that we're initializing the leaderboard with the name ScratchCat, but there could be a user called ScratchCat. We know there can't be a user called Scratch Space Cat, as spaces aren't allowed in usernames. So if we do that and we go to the all characters, and at the end of the all characters we press a space, just adding a space at the end there, we can now initialize a high score table with a name that can't exist as a normal username. I'd also like it to initialize with a variety of scores rather than just 100. And so we're going to set score with a little s, so it's for this sprite only. And we're going to set it to a multiply. And that multiply is going to be high score number, which is how many entries we have in the high score table, times by 100. And instead of adding 100, we'll add score. And each time we've added a score, we'll take 100 off it. So change score by minus 100. So if you consider high score number is 3, we have 3 entries in the table. The score will start at 300. So the first one will be 300, and then 200, and then 100. So we'll have a variety of scores. Now, in the code from the basic Cloud Leaderboard, we hard-coded it so that the length of a username was limited to 12 characters and the length of a score to 5 digits. But we didn't use variables for that, we just used numbers, and that is generally not a good idea. So I'm going to set up a couple more variables. I'm going to make a variable called max name length, for this sprite only. And I'm going to make a variable called max score digits for this sprite only. And I'll initialize those in this custom block. And I'll set them to the same values we were using before for now. So I'll drag it into there and again into there. And I'll make this one max name length, and I'll make this one max score digits, max name length set to 12, and max score digits set to 5. And now we need to look through the code to see where we should be using these variables. The first place is in get username. Repeat 12 has been hard coded to the value 12. It'd be much nicer saying max name length. Let's look further across. Encoding high scores. When we encode the name, again, it's being padded out to 12 characters. It should be using the variable. And I would assume in decode name, yep, it's also being forced to 12 characters. So let's set that to max name length. And now for the digits. When you're encoding the score, it makes sense that is hard coded to 5. So I'll set that to max score digits. And again, over here, decode score, max score digits. But while we're on the area of this encode score, this function can be greatly improved. Let's just move this comment out of the way. And let's see, at the moment we're using a modulus function to ensure that the score is no more than 5 digits. Now that we're been able to set the number of digits, I'm going to approach this in a different way. I'm going to set score. I'm going to delete everything in there, so score is just a blank. And I'm going to use the index variable. I'm going to set index to the length of, and I just drag score down. So if I'm looking at the index letter of score, I will start off with the last letter. So what I need to do is set score to join, and then the index, is that word indexed? Letter index of score to score. Okay, so initially this score is nothing. We're adding the last number of the score passed in, and then we're going to take 1 off the index. So we'll add the previous number and the previous number, and so it's just copying it across, but it's ensuring we end up with exactly max score digits. But we do need to check if this score passed in has less digits, then index is going to be a minus number. So we need to check that. So we'll put an if around the set score, take that change down here, and we're going to check that index is still greater than 0. So if index is greater than 0, then yes, we can add a letter. But if it isn't, I'm going to copy this. But what we need to add, instead of a letter, is we just need to pad it with the number 0. It will do a very similar function to what it was doing before, but in a nicer way that works for being able to change max score digits. And while I see these comments on the screen, these are slight tweaks that were made after the original tutorial. So this was a little bit of code that was missing from the original tutorial, which was just checking that if you actually had a score on the high score table and scored a lower one, it would add that as well, rather than ignoring it. It should only let you have one high score on the table. So that fixes that. So I'll get rid of that comment now. And there's also a comment up here, and that's about using an updated variable. I've actually added this variable, and all it does is when I've called update high scores, it's set to true if your high score has been added to the table, otherwise it isn't. So I will remove that now that I've explained it. There are also some minor changes to the text sprite, which were in the costumes. And looking right at the bottom of the costumes, I added a minus character and an underscore character because they're needed for usernames. Now let's have a look over here where I initialize the cloud data. You can see that I'm using my username to check that it's me hitting this block. It doesn't really matter too much because nobody else can change your cloud data, but I like to have it in there, just it makes me feel better. So I'm going to use that, seeing I've remixed it to my RokCoder channel, and I no longer need to do all this because it's all in initialize now. So instead of all of that, I can just initialize and encode high scores. And I'm actually going to get rid of this connected variable for reasons I'll explain in a moment. Well, the reason is when I update the high scores, it always reads from the cloud first. So if it can read the data, it will. And if it can't, it won't. But there's no way that it's possible to go into here and save the wrong data, save old data just because you weren't connected at the beginning. It's a redundant variable, so let's remove it. So we'll go up here and we'll move decode there, and we'll get rid of the if connected equals true. That's in code high scores, and in decode high scores, we're going to similarly move all of this code up here and get rid of that if that sets connected to false. And we're also going to remove the set connected to true, and then we can actually delete that variable. And the very last bit of neatening up I'm going to do is over here in update high scores. This is a receiver that's got loops in it, and so it would be far better if I made a custom block. Was it non-refresh custom block? And I call this update high scores. And I run it without screen refresh. And again, this just ensures that all the loops occur really quickly in one frame. And essentially I can move the entire of this function down here and just replace data including set updated there to false. And in update high scores, I then just need to call update high scores. And now this should work exactly as it did previously, but we're ready to do some more work with it. So let's reset the high score table, run the code, and you should see the high scores are initialized like that. Now I just want to check the piece of code where I set the username to make sure it's being done correctly. I put that in the wrong place. That should have been repeating that number of times. That was just I dragged it to slightly the wrong place. Reset the cloud data again, run the code again, tap the mouse. I've scored 350 and it's got it at the right place. If I score less, let's say I score 250, which should put me at the bottom, except I've already scored higher, so let's hope it ignores it. 250, and it's ignored it. Let's score 350 again, same score, it's fine. And if I score 450, I should go in at second place, and that one should be removed. Perfect. So it's working as we want, and it was well worth doing that quick test then. Something I would really like to add to this is the ability to have usernames with capitals or lowercase letters. To do that, we're going to have to add a function that tells us whether a letter is a capital or not. And for that, I'm going to have to add a costume. So just paint a new costume. I don't need to actually do anything in it, but I do need to change the costume name to, in all capitals, the full alphabet: A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Simple as that. And there is a reason for this. I'm going to add a new function. I'm going to put it over here, and I'll call it check case of character. Check case of character, colon. And then we'll add an input, and the input will be character. And we're going to run without screen refresh because, again, we want to ensure that all loops happen within a frame. I'm going to need to create a couple of variables, one called costume, which is pretty much the heart of how this works, and another, I'm going to need another index variable. I can't just use index because that's already being used at the same time, so I'm going to call this check index for this sprite only. We're going to start off with costume being an empty string. So set costume to nothing, just delete that. And we're going to set check index to 1. And what we're going to do is we're going to loop through the alphabet. So we need to loop through 26 times. Repeat. 26. And we're going to see if this character, check index character of the alphabet, is the same as the one we've passed in. If it is, we're going to use that letter. Otherwise, we're just going to use a capital. So it'll make more sense in a minute. So if it needs to be an equals. Now we're going to look in our, we've already filled this all characters list with the first 26 letters are all capital A to Z. So if item check index of all characters is character. So if character is a small case A, for example, then the very first test will say if A equals A, and it doesn't matter if it's a capital or not at this point, it's just saying that that is a character we've passed in. Now, if it is a character we've passed in, we're going to add that to the costume string. So set costume, I'm going to do a join. What's already in costume with our character. And so if we've got a capital A there, for example, it will add a capital A to the string. If it's a small a, it'll add a small a to the string. But if it's a different letter that's being passed in, I'll just copy this over and we'll just use the capital letter. So all this is doing is creating a costume with all the letters A to Z, but the letter we passed in, if it's a capital D, for example, then the string will be capital letters A to Z. If it's a small d passed in, it'll be capital A, capital B, capital C, small d, and then capitals for the rest. And the reason this works is that costume names are case sensitive, and we've made a costume with capital letters. So now what we're going to do, we're going to switch the costume to one that we know exists, costume 1, and then we're going to switch costume to the one we've just created, the costume variable we've just been created. If it does switch, then it means they're all capitals. If it doesn't, they're not. So now I'm going to make a new variable called is uppercase, question mark, because it's true or false for this sprite only. And I'm going to set is uppercase to a Boolean, checking the costume which is in looks to see if the costume number is 2. If it is 2, then we know it's changed costume and it's capital, so that's true, and if it isn't, it's false. So up here, where we're actually encoding the score, when we've set encoding the name, when we've set the character, we're going to quickly check the case of this character. Anything except small letters of the alphabet are going to come through as is uppercase is true. It's only going to be false if it's a small letter of the alphabet. And so we can now put around here just the character number bit. If it's uppercase, if it's true, then we'll just carry on as we normally do. Otherwise, it's a lowercase letter, and we know that we've stored all the capital letters immediately followed by all the lowercase letters in this list. So we can just duplicate that, and instead of the item number, we're going to change it to the item number plus 26, which will be the corresponding lowercase character. Now I just want to check the check case of character block to make sure there are no mistakes. Straight away I can see that I've forgotten to increase the index as I go through the loop, so I'd better fix that first. And quickly checking the initialize custom block, I can see that I haven't added the lowercase alphabet. So in there, after Z, I need to add A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. So now let's initialize the code and see what happens. And we have uppercase and lowercase letters working as we would want. So now, what happens if we want to have more than 5 names? I mean, more than 5 entries. So let's have 10 entries. And let's say each entry can have 14 characters and a larger score of up to 6 digits. I think there will be problems here. I'll reset the code, cloud data, and there's definitely strange things afoot in there. And the reason for this is because we're using one cloud variable, and a cloud variable can only store up to 256 characters, and we're now using a lot more than 256 characters. So we need to use more than one cloud variable. So let's see how we can do that. I'm going to add a little function here that we can just run ourselves if we need to, that tells us how many cloud variables we need. And I'll put it in this where we're initializing cloud data. And I'll call it cloud variables required for this sprite only. It's going to be a simple formula for this, and I can run it after I've initialized all the data, because then I know the max name length, the score digits, all the important information. So it's going to be high score number multiplied by, and then an add in there, and then a multiply in there. And I'll show you why. First of all, we want high score number, that's how many entries we're going to have in the table. And then we want the maximum name length, goes in there, but we're using 2 digits to store each alphabetical character, so that's times 2. And then we want the maximum score digits in there, and that's going to tell us the number of characters we need of cloud data. So if we divide that by 256, it will now tell us exactly how many cloud variables we need. Although it will be a fractional number, it might give 0.7 or 1.3. We need to round this number up. And to do that, we're going to use the ceiling function, which is in this mathematical block. Choose ceiling, and that will round it up to the next integer number. And so we will set cloud variables required to this. So now when I initialize the data, if I click on cloud variables required, it tells me I need 2. I have enough data that I need 2 cloud variables. So the first thing I'll do, I've got high scores. I'm going to rename that as high scores 1, and I'm going to make another variable called high scores 2, which is another cloud variable. Now updating the decode for the high scores is very simple. Let's go over to decode high scores, and when we're setting the cloud data, we just need to join high scores 1 with high scores 2. Obviously, if the size of your leaderboard needs more than 2 cloud variables, you're going to have to extend this. But now we need to look at the encoding. And the issue here is that cloud data needs to be broken into blocks of 256 characters. So I'm going to add a non-refresh custom block down here, and I'm going to call it break up cloud data. and it's going to be running without screen refresh to ensure all the loops occur in a single frame. And I'm going to make a new list called cloud data to store these separate sections in for this sprite only. So the first thing we do is delete everything in cloud data, make sure it's empty. And now we're going to have to step through the cloud data variable. So let's set index to 1. Start at the beginning. And we're going to repeat until we've gone through the whole thing. So that's repeat until index is greater than the length of your cloud data. So index is greater than length of cloud data. I'm going to make another variable called cloud where we're going to store this particular 256 character section. So we'll have to set that to nothing here. So we'll set cloud to absolutely nothing. And then we're going to repeat a loop of 256. And in there, we're going to build up that cloud variable. So we will set cloud to join what's already in that cloud variable with letter index of cloud data. And the beauty of this is, even if index has gone past the end of the cloud data, it will just return a completely empty string, so it will make no difference, it will work fine. Well, there we will change, not this uppercase, we will change index by 1, and at the end of that we will add this 256 or less characters section that we've made to cloud data. So now we've broken it up into several sections, as many as needed. So up here, up here we're going to, we don't want to set high scores like this anymore. So put that above. We need to set high scores 1 to item 1 of cloud data, and similarly set high scores 2 to item 2 of cloud data. And again, if you're using more than 2 cloud variables, obviously you have to extend that here using the same method. But there's one more thing. There's a stipulation: you can't write cloud variables too quickly. You need a space of 1/10 of a second between each write to stop people spamming the servers. And so we can't do this in a non-refresh block. I'm going to have to take this out of here. And over here where we've updated high scores, you can see that the calls to the encode are coming from here, which is in a non-refresh block. So we're going to take them out of here and out of there. And I know that if the cloud data has been updated, then this updated variable has been set to true. So what I can do, up here, I can say if updated is true, then I will encode the high scores, which is going to happen very quickly, and I will set the high scores, but in between those, I'll simply add wait for 0.1 seconds, or 1/10 of a second. And again, I will just clean this up. No, I don't think I actually added the call to break the cloud data up. I'll have to add a call here to break up cloud data. Encode high scores is no longer updating the cloud data itself. So I might as well copy this little block across. So that my initialization block actually updates the cloud variables. Initialize it, run it, and now they're all initialized correctly. I think one more thing I'd like to do is get rid of these zeros before the numbers. They're not really needed. And that's a very simple thing to do. I don't need to, in encode high scores, I don't need to decode them at the end. What I do need over here, when I've decoded a score, I will just set the decoded score to the rounded off value of decoded score, and that will change the string, which begins with zeros, into a number which will get rid of any leading zeros in the decode section. So if I run that, there we go, it's got rid of them all. Now obviously the display isn't perfect here. Tap mouse is happening on top of it. We don't really want that, but I can still test it. Say I scored 450. It goes in there fine. Let's score a bit higher. Score 750. Perfect. Let's score 250. It shouldn't change it, and it doesn't. That's great. Let's save this project. Reload it. And now comes a moment of truth, whether the cloud data will have worked correctly. Run it. And there we have it. We have 10 entries in our cloud data. So you can extend the number of letters in the names, the number of digits in the scores as much as you want. And I'll make one more tutorial about this. In that I'll show how you can display 50 or more high scores in a high score table that scrolls the scores up and down. Makes a nice display, as you may have seen in some of my previous projects. But this leaves you with a high score table you can use to store as many names and scores as you wish. So hopefully you enjoyed that. If you did, don't forget to subscribe to the RokCoder YouTube channel, and I'll see you next time.